These are the examples for Geometry A, Credit 4, Lesson 7.1. Our example for problem number 1 is we're trying to find a missing angle here. And recall that in any triangle, the sum of the three angles is 180 degrees. And so that's what we're going to use to set up our equation here. We have our missing angle x plus this angle 30 plus this angle 80. And again, the sum of all three angles is 180 degrees. Our next step is going to be combine our like terms here, our constant terms. 30 plus 80 is 110. And so we have x plus 110 equals 180. X is over here on the left-hand side, so that's what we're going to focus on. We have a plus 110. The opposite of adding 110 is to subtract 110 to both sides. The 110s over here cancel out, and we bring down the x, and 180 minus 110 is 70 degrees. So our answer for example number 1 is 70 degrees. Problem number 2, a similar concept. We just have a slightly different expression for our missing angle here, 6x plus 20. So we have 6x plus 20 plus 50. Let's go ahead and circle these as we write them. Plus, yes, that's 50, that's correct, plus another 50 equals 180 degrees. And again, it's because the sum of all three angles, 6x plus 20 plus 50 plus another 50 is 180 degrees. Once again, we're going to combine our like terms, our constant terms. So we bring down our 6x, and then 20 plus 50 is 70. 70 plus 50 is 120. So we have 6x plus 120 equals 180. Once again, x is over here on the left side, so that's where our focus is going to be. The opposite of adding 120 is to subtract 120 to both sides. The 120s cancel out. We bring down the 6x. 180 minus 120 is 60. Our final step, x is being multiplied by 6, so we're going to divide by 6 to both sides. And the 6's cancel out, and 60 divided by 6 is 10. So our answer is x equals 10. All right, for problems 3 and 4, we're going to be talking about exterior angles and remote interior angles and how they relate to one another. So let's take a look at an example for problem number 3. Let's go ahead and set this up. We use the same letters that they do in the packet. So we have G, T, V, and U. All right, our angle measures here. This will be X, this will be 87, and this will be 53. So what is an exterior angle? What is a remote interior angle? The exterior angle here is X, and an exterior angle is formed by extending one of the sides of the triangle and the side adjacent to it. So X is our exterior angle. Now, the angle next to it, the X here, is an adjacent angle. And so we don't want that. We want these two other angles, which are the remote interior angles. Let's go ahead and write that up here so we can be reminded of that. And so the relationship between the exterior angle and the two remote interior angles is that the sum of the two remote interior angles equals the exterior angle. Or we could say the exterior angle X is equal to the sum of the two remote interior angles. And once again, with sum, that tells us we're going to be adding 87 plus 53, and we get 140 degrees. So X equals 140 degrees, or we could say our exterior angle measures 140 degrees. All right, problem number 4, our example for that one is, once again, we're going to be dealing with exterior angles and remote interior angles. And for this one, we have this is 140, this is 100, and there's a question mark here. We're just going to put X there. And we'll use, again, the same letters that they use. And let's go ahead and solve for our missing angle here. So once again, we have an exterior angle. The angle next to it is the adjacent angle. And recall that the sum of the two remote interiors, so x plus 100 equals our exterior angle, which is 140. So x is over here on the left-hand side, so we're focused over there. We have a plus 100, so we're going to subtract 100 to both sides. The 100s cancel out. We bring down the x, and 140 minus 100 is, fix that there we go, is 40. And so our answer is x equals 40 degrees. All right, so now let's take a look, going over to page 24. Once again, we're going to be working with exterior angles and remote interior angles. Just the expressions are going to be, well, you'll see here right now, a little bit different. Not hard at all. All right, so let's take a look at an example here for problem number 5. And we'll draw that very similarly here. We've got 5x plus 10 here. And this is 4x. And this is going to be our exterior angle will be 145 degrees. All right, so let's go ahead and set this up. Our two remote interiors, we add those together. So 4x and then 5x plus 10 equals our exterior angle, which is 145 degrees. And so our next step is to combine like terms. This time our like terms are the x's. 4x plus 5x is 9x. So we have 9x plus 10 equals 145. Once again, x is on the left-hand side here, so we're focused on the left. We've got to get rid of this 10 and this 9, so we have adding 10 or plus 10. And the opposite of adding 10 is to subtract 10 to both sides. The 10s cancel out. We bring down the 9x. 145 minus 10 is 135. Our last step is x is being multiplied by 9. And so we're going to divide by 9 to both sides. The 9s cancel out. And 135 divided by 9 should be 15, but let's just confirm that here. Yeah, it is 15. So the 9s cancel out. We bring down the x, and again, our answer is 15. All right, looking at an example for our last problem in this lesson, number 6. And let's go ahead and set up the diagram in a similar fashion. Once again, we have some letters here, so we'll use those. And there we go. All right. So for our example, this will be 10x plus 9 degrees. This down here will be our exterior angle, 15x plus 7 degrees. And this angle up here will be 48 degrees. Make sure we got this all set up correctly. And that looks good. All right. So once again, we have our exterior angle, remember, formed by extending a side and the side adjacent. So 15x plus 7 equals, remember, we don't want the adjacent angle, we want the two remote interiors. So 10x plus 9 plus the other one, the 48. All right, so we've got some like terms to combine over here. 9 plus 48 are the two constant terms. So we're going to bring everything else down. 9 plus 48 is 57. So now we run into the situation of variables on both sides. We don't want that. It's a little bit easier if we get rid of the variable term that has the smaller coefficient. So since 10 is smaller than 15, we're going to get rid of the 10x. Since we're trying to get rid of the 10x and not just the 10, we're going to subtract 10x to both sides. 15x minus 10x is 5x. We bring down the 7. Of course, the 10x is canceled. That's the reason why we subtracted 10x. And then we bring down the 57. Our next step, we're focused over here on the left because that's where the x is. We have a plus 7, so we're going to subtract 7 to both sides. The 7s cancel out. We bring down the 5x. 57 minus 7 is 50. And the final step here, x is being multiplied by 5. So we're going to do the opposite of that and divide 5 to both sides. The 5s cancel out. We bring down the x. 50 divided by 5 is 10. So x is 10. Now in this one, they're also asking us to find the measure of angle U. Make sure we get that right. Angle UTQ. So where is angle UTQ? Well, we can just trace that to find out UTQ. One more time, UTQ would be our exterior angle here, which is the 15x plus 7. So we're going to take that expression, substitute our answer in for x here. 15 times 10 plus 7. Order of operations says we multiply before we add. Let's make sure we move that over so we can see that okay. 15 times 10 is 150, plus 7, I'm running out of room there, is 157. So the measure of angle UTQ is 157 degrees. Make sure we got that right. That looks good. And that is it. All right, so that is it for our examples for lesson 7.1. Again, pause, rewind the video as needed. I'm sure you're going to do great with these problems. Just give yourself time and to study and to understand everything. And again, I think you'll do great. So good luck with the work, and we'll see you in the next video. Until then, take care and God bless.